Hello, students. Today we're going to go over the 4.4 notes in Algebra 2, solving quadratic equations. There are various methods you can use to solve quadratic equations. We're going to start by going over solving by factoring. So when you're solving by factoring, you first make it equal to 0. 0 equals 6x squared minus 7x minus 20. From here, we want to factor it. 0 equals 2 sets of parentheses. And then we have to figure out how to factor it. For 6x squared, I'm going to go ahead and try using 3x and 2x. For 20, we have to determine if we're going to use 2 and 10, 20 and 1, 4 and 5. So I am going to use 4 and 5. If I check this, I get an 8 in the middle and a 15 on the outside. If the 15 is negative and the 8 is positive, so put signs accordingly like that, we will get the negative 7 in the middle. Now that it's factored, you want to make sure you factor it correctly. We're going to use something called the zero product property. That's where we split it up and make both sets of parentheses equal to 0. And then we solve. So I'm going to subtract 4. I get negative 4 equals 3x, and then divide by 3. So I get negative 4/3 for the first x value. For the second one, I add 5. I get 5 equals 2x, and then I divide by 2 to get 5/2. So our answers for this problem are negative 4/3 and 5/2. For the next problem, we're going to follow the same process. So to do that, I'm going to make it equal to 0 first. 0 equals 8x squared plus 22x minus 6. Now I do notice that 8, 22, and 6 are all divisible by 2. So I'm going to factor out the 2 first. Then I get 4x squared plus 11x minus 3. This makes it a little bit easier to factor. Make 2 sets of parentheses to factor the 4x squared plus 11x minus 3. Now I know the 3 is prime, so we have to use 3 and 1. I need to determine if I'm going to use 4 and 1 or 2 and 2. I believe I'm going to use 4 and 1. It'll be a 1x there and a 4x here. That'll give us a 12x in the middle, a 1x on the outside. So to get that middle term, this needs to be a positive 12x, so a positive 3. This needs to be a negative 1. Now that I have it factored, I do split it up using the zero product property. Now notice if we used zero product property and said 2 equals 0, that's not a true statement. We can ignore that too. We're going to say that x plus 3 equals 0 and 4x minus 1 equals 0, and then solve. I'm going to subtract 3. So I get x equal to negative 3. For the next one, I add 1. 4x equals 1 divided by 4. So I get x equals 1/4. So our answers are 1/4 and negative 3. And that's it for that problem. Now the next method we're going to look at is the quadratic formula. You use the quadratic formula when you can't factor. So the easiest method of solving is factoring. We jump to quadratic formula when we can't factor. First, we do have to make this equal to 0, so we need to move that 7 by subtracting it. That gives us x squared minus 5x minus 7 equals 0. This is not factorable, so I use quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. You may recall learning this in Algebra 1. Remember that a is the coefficient of x squared, b is the coefficient of x, and c is that last constant. So for this problem, our a is 1, our b is negative 5, and our c is negative 7. When I substitute, I get negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative 7. Notice how everything fits under the square root. And then for my fraction, I am going to extend my fraction line underneath everything. And I'll have 2 times 1. Now I'll simplify. The 2 negatives in front of the 5 become a positive 5 plus or minus the square root of negative 5 squared is 25. Negative 4 times 1 is negative 4 times negative 7 is a positive 28, all over 2. 25 plus 28 will give us 5 plus or minus the square root of 53, all over 2. And since we don't know the square root of 53 and that root cannot be simplified, we'll leave it as is. So we're actually done with that problem. That's all we have to do for that one. If the radical could be simplified, we would want to do that. But again, it's a prime. We're not going to be able to simplify that. Okay, for the next one, follow the same process. Our A is 1, our B is negative 6, and our C is 10. X equals negative B plus or minus the square root of B squared minus 4AC all over 2 times A. So X equals negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 10 all over 2 times 1. X equals positive 6 plus or minus the square root of negative 6 squared is 36 minus 4 times 1 is 4 times 10 is 40 all over 2. X equals 6 plus or minus the square root of negative 4 over 2. Since this is a negative number, we cannot go any further. This has no real solution. So it's important that you put the word real in here, no real solution, because there is an imaginary solution, but we have yet to go over that in this chapter. The next method we can use is the square root method. So this is if you have a single quantity squared, like in these examples, you can use this method. For the first problem, to get the x squared alone, that's always our goal, is to get the squared quantity alone. I first need to add or subtract numbers to move them. So I'm going to move that 15 by adding it to both sides. I get 2x squared equals 80. Then I'm going to divide both sides by 2 to x squared equals 40. At this point, now that the x squared is alone, I can square root both sides. This becomes the absolute value of x equals the square root of 40. Square root of 40 can be simplified. I am going to simplify that. Absolute value of x equals the square root of 4 times the square root of 10, which means the absolute value of x can equal 2 times root 10. Now I'm going to go ahead and split it up. Because it's absolute value, we have two answers. X can be a positive 2 root 10. X can be a negative 2 root 10. And now we're done. We'll get that squared quantity alone in the second problem as well. So in order to get the x minus 2 squared alone, I have to move that through by dividing both sides by 3. This gives me x minus 2 squared equals 20. At this point, now that the quantity squared is alone, I can square root both sides. The reason I'm square rooting first is because that minus 2 is stuck in parentheses. I cannot move it until the squared is gone. So now this becomes absolute value of x minus 2 equals the square root of 20, which can be simplified, square root of 4 times the square root of 5. So the absolute value of x minus 2 equals 2 root 5. At this point, I'll split it up. X minus 2 equals positive 2 root 5. X minus 2 equals negative 2 root 5. We'll add 2 to both sides. These are not like terms, so you have to write it as 2 plus 2 root 5. Same for this other problem. When we add 2 to both sides, it becomes x equals 2 minus 2 root 5. Now we're going to look at something called the discriminant. The discriminant is b squared minus 4ac, and it tells you the number of solutions you'll have in a quadratic. Okay, so you'll use the same a, b, and c you used in quadratic formula. Okay, notice this is actually out of the square root in the quadratic formula. So you'll substitute for a, b, and c. And if you get a positive number when you simplify that, you have two real solutions. So what that means is that you will have two intercepts for your parabola. When you graph it, you'll have two intercepts on the x-axis. If you get 0 for your discriminant, that means you only have one real solution. So that means you're only hitting the axis once. If you get a negative number when you simplify your discriminant, you only have imaginary solutions. So what that means is you don't have any real x-intercepts at all. Okay. Now we're going to go ahead and take a look at writing a quadratic equation. It says write a quadratic equation in the form ax squared plus bx plus c equals 0, where a, b, and c are integers. The roots of the equation are 3 and 1/2. So what this means is roots are answers for x. They're solutions. So that means for this problem, x is equal to 3 as an answer, and x is equal to 1/2. So we're actually going to work backwards. Instead of solving for x, they gave us x, and we're going to work backwards to create our equation. So to do that, we first need to make each of these equal to 0. I'll begin by subtracting 3 from each side. So I get x minus 3 equals 0. For this next one, I'm going to subtract the 1/2. So I get x minus 1/2 equals 0. But I don't want to deal with that fraction. So to get rid of it, I'm going to multiply everything by the denominator, which is 2. If I do that, 2 times x is 2x. 2 times 1/2 is 1. So now that'll be much easier to use when we go to make our equation. We're going to use this 2x minus 1 and x minus 3 as our factors of the equation. So if I'm working backwards, now I multiply these together. X minus 3 times 2x minus 1 equals 0. And then I would actually FOIL to get my final answer. So x times 2x is 2x squared. X times negative 1 is negative 1x. Negative 3 times 2x is negative 6x. And negative 3 times negative 1 is a positive 3. Then I simplify the middle term to get 2x squared minus 7x plus 3 equals 0. And that's my final equation. So again, notice we just worked backwards, right? Originally, in the problems before, the previous examples, they would give us this equation. We would factor it. We would use the zero product property and solve to get the answers. We just did the reverse here to write the equation. And that's it for today's notes. If you have any questions, be sure to contact your teacher.